Hello students, welcome back to my channel. In today's lecture we will be discussing about very important theorem related to moment of inertia, that is parallel axis theorem. This is very important theorem related to moment of inertia of body. Another theorem which is very important related to moment of inertia is perpendicular axis theorem, which I discussed in previous lecture. In case somebody has missed that lecture, can then found the link to that lecture in the description of this video. So moving back to our parallel axis theorem, what it states that moment of inertia of a body about any axis is equal to moment of inertia about an axis parallel to given axis passing through center of mass plus the product of mass of the body and square of distance between the axes. Now I will one by one just explain this theorem. What it say that if I have this planar body and I want to find moment of inertia about any axis, let this be n cap, let this be axis A, about any axis, then what will be the moment of inertia of this body? It will be equal to, let us say I call it as I about A, because I have to find the moment of inertia about A. It will be equal to sum of, here I have written it is equal to, I am using the word plus, means it is equal to sum of moment of inertia of the same body about an axis passing through center of mass, and this axis B axis is passing through center of mass, passing through center of mass. Okay, I write it as Cn because it is moment of inertia passing through center about an axis passing through center of mass, keeping in mind that this axis A and B, axis A is parallel to axis B, plus if R is the, if I say let us say if D is the perpendicular distance between the two bodies and M is the total mass of the body, plus it will be plus md square. So this is what is stated by parallel axis theorem, that is if I have to find moment of inertia about any axis of a body, let us say I have to find moment of inertia of a body about axis A, then it is equal to the sum of moment of inertia of a body about an axis which is parallel to A axis but passing through center of mass. Let us say center of mass somewhere lies here. Okay, plus product of total mass of the body and d square, that is perpendicular distance between the x's. So moving towards the derivation of the result, proof of the result, what I do is I consider here an elemental mass dm. I consider here origin O. Let this distance be capital R. Distance of elemental mass from the origin O is R, and the distance of elemental mass from center of mass is R dash. So moving towards the proof, remembering the formula of moment of inertia, dm n cap cross r square. Here I have considered r is the position vector of center of mass, and r is the position vector of dm, and r dash is the position vector of dm with respect to center of mass. I am going to show you the figure again. Capital R is the position vector of center of mass from the origin. Small r is position vector of dm. Small r is position vector of dm, and r dash is position vector of dm with respect to center of mass. R dash is position vector of dm with respect to center of mass. So considering this triangle, we can write it as r is equal to r plus r dash. Now my purpose is to first of all find the value of n cap cross r. So I will be finding the value of n cap cross r square. It is equal to n cap cross, the value of r here is r plus r dash whole square. It comes out to be n cap cross r plus n cap cross r dash. It's square. Then squaring, we get n cap cross r whole square plus n cap cross r dash whole square plus, I am using here the formula of a plus b whole square, plus n cap cross r dot n cap cross r dash. I substitute this value of n cap cross r whole square in this equation, of I cap. Then what do I get? I n cap, it is equal to dm n cap cross r vector square plus dm n cap cross r dash square plus 2dm n cap cross r dot n cap cross r dash. I am going to solve this equation. Keeping in view the figure we have drawn, n cap is here, r is here. So n cap cross r becomes d. It is a perpendicular distance, remembering that small d is the perpendicular distance between two parallel axes. Therefore, I get it as, we know n cap cross r, it is equal to d, that is distance between parallel axes. Therefore, I write it as A, because here I am finding the moment of inertia about axis A. So IA, it is equal to d square dm plus dm n cap cross r dash square plus twice n cap cross r dot n cap cross r dash dm. Here I have taken n cap cross r out of the bracket because capital R, n cap is also fixed, and capital R, that is the distance of center of mass from the origin, that is also fixed. Now let n cap dash be unit vector along axis B. Here n cap is unit vector along A, and I say that n cap dash is unit vector along B. But keeping in mind, since A is parallel to B, therefore n cap is equal to n cap dash. Now again considering this equation, I get moment of inertia about axis A, it is equal to, now this integration of dm, this integration of dm becomes total mass of the body, m d square plus dm n cap dash cross r dash square plus 2 n cap cross r dot n cap cross r dash dm. Of course, where m is equal to integration of dm, that is total mass of body. Now this term, the second term on right hand side of this equation, that is integration of dm n cap dash cross r dash square. Basically, what does it represents? It represents the moment of inertia of a rigid body about an axis passing through axis B. N cap dash is the unit vector along axis B, and remembering that axis B is passing through center of mass. I am repeating, I have considered n cap dash as a unit vector of axis B, and B is passing through center of mass. So this term, it is the moment of inertia about axis B, which is passing through center of mass. Therefore, this equation I can write it as IA, it is equal to m d square. As I discussed, second term represents the moment of inertia about center of mass, ICM, plus 2 n cap cross r dot n cap cross r dash dm. So this further, if I see this term, here n cap is, since it is only in one direction, I can write it as Ia is equal to m d square plus ICM plus twice n cap cross r dot n cap cross r dash dm. Now if we focus on this term r dash dm, this term is position vector of, this is position vector of center of mass in a coordinate system where origin lies at center of mass. What I mean to say is that if I consider, because I have shifted whole system to the center of mass system, and dm is the position vector of elemental mass from the center of mass, and if I have shifted my origin to center of mass, then of course r dash will be equal to 0. Hence this term it is equal to 0. Therefore I can say that r dash dm, it is equal to 0. Hence the moment of inertia about any axis of a body, it is equal to sum of moment of inertia about the axis passing through center of mass and product of mass and perpendicular distance, square of perpendicular distance between the two bodies. Thank you. That's all for today's lecture.